All right, so this is Thursday, and we are in lesson 4.8, picking up where we left off in the notes. Okay, we were trying to write this equation of this parabola. So I told you the easiest way to do this is to start in vertex form, plug in your vertex, which I did in green, and then plug in at any point on your parabola, and you kind of have to figure out what your A is, what your constant in front is. We talked about how it made sense that we got a negative because we have a sad base parabola that's a little bit wider, so we knew that factor should be some type of number in between 0 and 1, so negative 1/2 made sense. So this would be my equation in vertex form, where I can see my vertex. However, they did ask us to put this in standard form. So in order to do that, we know how to convert from standard form to vertex form. We do that by completing the square. So to go from vertex form to standard form, it's actually easier. Just do a lot of multiplying. All right, so we're going to have to do negative 1/2 times x plus 3 squared, which I'm going to do that first, which is x plus 3 times itself twice. And we're just going to multiply this all out and then combine our like terms. Okay. So, like I said, I would do these first. I'm going to do this in one step because hopefully we've got a lot of practice of multiplying binomials. We have x squared, and then I have 3x and 3x would be 6x. Okay, I'm just adding them in one. And then I would have 9. That's how that would multiply out. Then I just have to distribute the negative 1/2. So I get negative 1/2 x squared. Half of 6 is 3, so I become negative 3x. Half of 9, negative 9/2. All right, so the only thing I need to do to put this in standard form then is just add these numbers together. So think of 6 as 12 halves minus 3 halves, minus 9 halves, we get 3 halves. Okay.
Nice.
And that would be in standard form, what they asked for. So start in vertex form, figure out what that A factor is, and then convert it to standard form. That's the easiest way to do it because there's really no way of like jumping right to standard form when given like the vertex and a point because we can't plug those in anywhere. We have to start in like that vertex form. There's one more later on that we'll do similar. Okay, so that's technically a little bit of just review of graphing parabolas. All right, so we graphed one in like that factored form. We've looked at these 3 different forms, but what we're really focusing on from now on is quadratic inequalities. So we've graphed inequalities before. These are these symbols, less than, greater than, less than equal to, greater than equal to. Do you guys remember there's like 2 differences when we're graphing equations versus graphing inequalities? There's 2 differences. Can somebody give me one of the differences? Connor.
Dash and solid line.
Good. Dash or solid line, but now we're just going to do dash or solid parabola. Okay. What's the other difference? We got shape. Because we have to represent all of the y values that are greater than this parabola. Okay? So this is just, again, more review for graphing, but now applying it to inequalities. So here's kind of like the steps you can follow and the ones that you should follow in your homework. What form is this in?
Standard.
Standard form. The first thing we're going to do is complete the square to put this into vertex form. So let's go ahead and do that. Now you can change this to an equal sign in your work if you want to. You can keep it as a greater than, whatever you want to do. Just keep in mind, like when we go to actually graph it, we're going to have to use that symbol to decide solid or dash and where to shade. Okay, so to complete the square, here we go, round 6. Group the x's. Make sure there's a 1 in front. There is not, so I need to factor out a negative 1, which would leave me with x squared minus 4x. Leave a big gap. All right. I got to take half of negative 4 which is negative 2, squared, which is positive 4, and that's what I add. Okay, team.
4 plus 4.
I really have to add 4. Good. Because I really added in a negative 4. So I got to counterbalance it by adding 4. Good job. Let's see if my new red marker works. Oh, beautiful.
Whoa, look at that.
All right, so this factors then to x, half of negative 4 is negative 2 squared. And then I have that negative 1 out in front. And then I have plus 5. Boom. First step done. Complete the square. Oh, I guess I do have to identify the vertex. So what would my vertex be?
5.
2, 5. You betcha. 2, 5. We're in vertex form now. We can tell what the vertex is. 2, 5. Okay, that's done. Complete the square. Identify the vertex. Let's go ahead and plot our vertex. 1, 2. Is this going to be a U up or a U down?
Down.
U down. So am I going to have x-intercepts? Yes, I'm going to. All right. So that's the next thing you're going to do. Just like normal when we graph, we find the x-intercepts. So x-intercepts, this is a good review for the quiz too, is when y is 0. So you're just going to treat this as like an equation. You can change it to an equal sign because I want to find where y is equal to 0. Where y is equal to 0. Okay, I'm going to do this quickly. I'd subtract over the 5. Divide by negative 1. Square root both sides. And add over the 2. I don't mean to rush through this. We've done a lot of practice of this, so hopefully we're getting comfortable with that. Now on the quiz, I just looked at the quiz on Monday. You want to leave your answers if they ask you to find the x-intercepts. You want to leave it in exact form. All right? But in order to graph it, if you need to jot down what the decimals are so you can plot it easier, do that. So here's the decimals I got for that. I got about like 4.2360, yada, yada, yada. Negative 0.2360, yada, yada, yada. And then I'm like, okay, that's easier to plot. So negative 0.2 would be here, and then 1, 2, 3, 4. 0.2 would be about there. If my vertex would have been 2, 5 and it was U up, and there weren't any x-intercepts, how would I graph it?
Helper.
Find a helper point. Yep, just find any point on the parabola to graph it. All right, don't connect your dots yet. Don't connect your dots. Because we're not just graphing the parabola, we're graphing the inequality. So look at my symbol here, solid or dashed?
Dash.
Dashed, because it's not equal to. So you got to dash those. Make it look like a parabola. All right. So draw the parabola passing through any x-intercepts, dash your solid, and shade the proper side. All right. So how I like to do these, and you can always use a test point. If you want to test like 0, 0, because you can see it lies inside your parabola, you can always use a test point. But I like to read this out loud. I want to shade where all of the y values that are greater than this, which that's my parabola. So looking here, see how it crosses the y-axis at about, well, it should cross the y-axis at 1, right? That's my y-intercepts, but, so you could have graphed that point if you wanted to. Where are my y values greater than 1? Would it be above, outside my parabola, or would it be below all those x values that are inside my parabola? Outside, right? Those are the y values that are greater than. If you want to shade greater than your parabola, that's everything outside.
So is it always outside then if it's greater than?
Nope.
Uh-oh.
It depends on what kind of parabola it is. If it's U up, U down. Yes. Good question. We'll do another one. And folks, if you're ever not sure, use a test point. Pick a point, hey, 2, 0 clearly lies inside my parabola. Plug in 2, 0, you'll see it's a false statement. So you're like, okay, that's not a solution. Because you're shading all of the possible points that I could plug in here and you get a true statement for the inequality, right? So, or you could do it the other way, like pick a point that's clearly outside, plug it in. Oh, that's a true statement, so I need to shade that side that includes all the solutions in that inequality. That's why we shade. There's infinitely many ordered pairs that I can plug into this inequality and it'd be a true statement. Then I get like 10 is greater than 7. 15 is greater than -1. Like there's infinitely many solutions there. All right, let's try one more. Okay, first things first. What form am I in?
Standard.
Standard. So I gotta put this in vertex form. Group the x's. Looks like I need a factor out of 2. All right, I got to take half of -1, which is -1/2, square that, which is a 4th. So I'm going to add a 4th in here. What did I really add, though? What's 2 times a 4th? 1/2. So I really added in a 1/2. So I got to subtract a 1/2. Don't let the fractions fool you. So then this factors in to x minus 1/2 squared. -3 minus another 1/2 is -7/2. Okay, everybody okay with that? So my vertex would be at 1/2, -7/2. Again, if it helps you to think of this as decimals to plot it, that's fine. Just keep in mind, like when I ask you for an answer, we want to use fractions, use exact. All right, so my vertex is 1/2 -3.5. Is this you up or you down? You up. So I'm going to have some x-intercepts. Another point we could plot, look at my standard form. I could plot -3 if I wanted to. That's my y-intercept. You could plot that if you want. You should, really. Okay, let's quickly find the x-intercepts. So x-intercept is when y equals 0. I'll do this one with you since there's fractions. Add over the 7/2. Divide both sides by 2, we get 7/4. Square root both sides. All right, and then I'm going to add over the 1/2. So I end up getting x equals 1/2 plus or minus the square root of 7 over the square root of 4 is 2. Okay, I did that kind of quickly, so let me just verbally explain that again. So square root both sides. Over here, I simplified it. Square at the top, square at the bottom is a perfect square. Square root of 7 over 2, no rationalization needed. Then I added over that 1/2. Okay, so again, this is how I'd want you to write your answer, exact. But as decimals, practice typing this in your calculator. Oh, and on the bookwork, they only give decimals. So you need to check your exact answer, get the decimals, and make sure you got the right answer because they don't tell you the exact answer. I did on the worksheet, I gave you exact answers and decimals, but on the bookwork, they're only going to show you this. So type in, and that's good practice. Make sure you know how to type something like that in to get the decimals approximation, which helps us graph too. So -0.8 is right there. 1.8. This is a skinny guy, which makes sense because we have this 2 factor in front, which is a vertical stretch, which makes my graph skinnier. Dashed or solid here, folks? Solid because it's equal to. Good. Solid. Okay. Now, Carter, here's a great example of your question. My symbol's greater than, right? My symbol's greater than. My y-intercept is right here. Where are the y values greater than -3? Below, which is located outside, or above, which is located inside? Above, so we'd shade inside this time. So it just kind of depends on where your parabola is positioned, and also if you have like a happy face or sad face. James, hi! We're recording for you. So I'm going to stop the recording right now so you don't have to go any further. And
You flunked your
James.
test. You flunked your